Welcome back to the deep dive. This is where we take the sources you find interesting and, well, we dig in.
That's right.
Today, we're looking at some materials you sent over from Polytech Educational Technologies. It's all about their smart block system.
Yeah, it looks like we've got descriptions and programming steps for a bunch of different activities using these blocks. Educational tech stuff.
Right. So, our mission today, I guess, is to figure out what you can actually do with smart blocks. What kind of coding and electronics ideas does it teach?
Exactly. To see the range from simple stuff to maybe more complex projects.
Okay, so the documents kick things off with a guide to their programming tables. It looks like there are 4 columns.
Uh-huh. Yeah, 4 main columns to help structure the programming in their visual software. R.icon.
First one's indentation. Now, is this just formatting or...
Well, it looks like formatting, but it's actually functional. It shows the code structure. You have to start at the first indentation level, and the software helps you move in and out to nest commands like putting actions inside an if statement. It's about logic flow.
Ah,
Yep.
okay. So it dictates where in the sequence or logic a command sits.
Precisely. Then you've got the command column.
Right. This sounds like the action itself, like digital write.
Exactly. It's the verb,
Yeah.
What do you want the system to do? Things like if then, digital write, delay. There's a panel in the R.icon software where you pick the command you need.
Okay. Next up is device. So this is the hardware.
Yeah, the physical component. An LED, a tuck switch, a sensor. You select the specific piece like a DJS08 touch switch or maybe a DJX07 green LED from a list in the program.
So the software knows about all the different blocks.
It seems so.
Oh.
It connects the software command to the actual physical thing you plugged in.
Makes sense. And the last column is port state. What's
Yeah.
that handle?
That gives the specifics for the commanded device, like which port on the controller is the LED plugged into, port 8, port 9, and what state should it be in, ON, RF.
Okay, so the example they give is like, if the touch switch is also F.
Right, then maybe turn on the green LED. It links the input condition to the output action, specifying all the necessary details.
And you build this all visually in R.icon, and then it generates the code.
Yeah, it generates Arduino and C code behind the scenes, which is
Sure.
pretty cool. You can even see it if you want. Then you upload it, and the software tells you if it worked or if maybe a device isn't found.
Gotcha. Okay, foundational stuff covered. Let's look at some actual activities, starting with 5th grade.
Sounds good. First one listed is 85-20, an advertising sign.
Aimed at understanding digital write and delay, it says, using red, yellow, and green LEDs.
Yeah, the idea is simple sequencing. Turn the yellow LED on, wait a bit using delay, turn it off. Then do the same for green, then red.
Like flashing lights on the sign.
Exactly. It's all about controlling outputs over time.
Yeah.
You use digital write for on/o off,
Mhm.
and delay, they use 500 milliseconds here to control the timing. Simple, but teaches sequencing.
Okay. Then there's 86.26, a pedestrian traffic light. This adds a push button and a buzzer.
Right, so now we're bringing in input. The goal here is understanding digital read, checking the button state, and if-then logic, plus the digital write and delay we just saw.
So if the button is pressed,
If the button DJS09 on port D6 is on in, then the green LED D9 and buzzer D8 turn on, the red LED D7 turns off, and it waits for 5 seconds.
and if it's not pressed,
That's the else part. Red LED on end, green and buzzer on end. Classic conditional control. You press the button, things change.
trick cause and effect.
Mm.
Next, 5th grade one, 86.28, automatic city lights, uses a motion sensor.
Yeah, similar concepts, digital write, digital read. But now the input is environmental. A motion sensor, DJS19.
So if it detects motion,
If DJS19 is on, then it triggers a sequence. Green LED, D9 on for 5 seconds, then off. Then yellow, D8 on for 5 seconds, then off. Then red, D7 on for 5 seconds, then off.
like street lights coming on as someone passes.
Sort of, yeah. Or maybe security lights. If there's no motion, the else condition keeps all the LEDs off. It shows sensor-based automation.
Okay, moving up a notch. 6th grade, AC 1.24, a goniometer. What's that?
It measures angles. This uses an angle sensor, AGS06, which is an analog reading, not just OF.
Ah, so not digital, and it uses different colored LED.
Right. The goal is understanding analog read and, importantly, nested if statements.
Nested ifs, so ifs within ifs.
Exactly. The logic is, if the angle reading from A1 is less than 30, all LEDs are off. Else if it's 30 or more but T less than 90, turn the green LED D9 on. Else if it's 90 or more but less than 120, turn yellow D8 on, so on, for red and blue LEDs at higher angles.
So different angle ranges trigger different lights, more complex conditions.
Definitely. You're mapping a continuous input range to discrete outputs using multiple nested conditions.
Okay. Next AC 2.13, greenhouse temperature and humidity control. Sounds practical.
Very. It uses a temperature and humidity sensor, MJS22, and a soil moisture sensor, AJSO5. The outputs are a fan represented by a step motor, DJX09, and a watering machine, which is just a red LED, DJX06.
So it's reading multiple sensors and controlling multiple outputs.
Yes, and using more complex logic with if, else, if, and else. For example, if temperature is 20 or more and humidity is less than 60, then turn the red LED and fan on.
Okay, like it needs water and cooling.
Right. But then if humidity is high, 60 plus, but it's still warm, 20 plus, then turn the LED off, no water needed, but keep the fan on.
Ah, different combinations, different actions.
Exactly. There are clauses for just needing water, humidity low, temp okay, and for when everything's fine, both LED and fan off. It models a real control system.
Last sixth grade one, AC 2.13, dual switch magnetic card 2, magnetic switch, and a light sensor.
Yeah, an LDR light-dependent resistor, AGSO3, which is another analog sensor measuring light levels, and a magnetic switch, JGS15, which is digital on N if a magnet is near, OFF if not. Controls blue and yellow LEDs.
So combining digital and analog inputs, how does the logic work?
It's nested again. Yeah. First, the magnetic switch D7 detects a magnet as a lean in. Then it checks the light sensor, A2.
Okay.
Inside that magnet present condition. If the LDR reading is less than 50, it's dark. Then turn both blue, D9, and yellow LEDs on.
Like a security light and an indicator?
Maybe. Then if the LDR is 101 or more, it's bright. Then turn only the blue LED on, yellow off.
Interesting. And if the magnet isn't there?
That's the top level ELSE. If the magnetic switch is OFF, then both LEDs are OFF, regardless of the light level.
Wow, okay, so you really see progression there. From simple flashing lights to reacting to buttons, then sensors, then multiple sensors, and complex nested logic.
Absolutely. It seems like the smart block system provides this structured pathway. You start with basic outputs, introduce inputs, then conditional logic, analog sensors, and finally combine them into more sophisticated interactive systems. You build complexity step by step.
And you get that immediate feedback, seeing the physical blocks respond to the code you've built visually. That seems key.
It really is. That connection between the abstract code and the tangible result is powerful for learning these concepts, from simple sequences to, automated greenhouse control or security logic.
It really makes you think, doesn't it? Taking these fundamental pieces, sensors, logic, outputs, what could you build? How could these simple ideas be combined to, I don't know, solve a little problem in your own space or just create something interesting?
That's the spark, isn't it? Seeing the building blocks and wondering what else is possible.
Definitely something to mull over. Thanks for diving into these smart blocks activities with us today.